Good morning, everyone. This is Jerry Hovdestad from AirBorn and now a Molex company. It's really nice to be back here and see a lot of familiar faces. Seen you all for a long time, and I'd like to thank Jerry for putting this on. I think we have been seeing a consistent message from all the presenters, VITA 100, all of the advances going on, and I think this venue helps to get the message out to the industry, just to give everybody a good view of what's happening. And my talk today is about VPX power again, but an unusual application for the VPX power, and just to show how flexible it can be, not covered by a standard, but the power supply is developed. You can do a lot of different things. A little bit about AirBorn. We've been doing 6 decades of connectors and interconnects and power systems. We've been doing it for over 30 years. We have designs in just about all the military platforms, and power designs from 50 watts up to 300 kilowatts. And AirBorn is a very vertically integrated company. We have machine assembly, we have power supplies, we have connector assembly plants all over the place. And with Molex now, I think they're in 20 countries and they have 85 plants around the world. So gives us a little bit more flexibility and ability to take advantage of a bigger operation. So today, talk a little bit about PlugFest. As you heard in a bunch of the presentations, the new secretaries of Army, Navy, Air Force have reaffirmed their love of MOSA and how they want everybody to use modular open system architecture. And to publicize it, the government, Air Force in particular, has been holding PlugFests. And they had a preliminary PlugFest in Atlanta, basically the beginning of December. And we were invited to go down there and show our products. They basically wanted people to show off. If you have a card that's aligned with the standards, they wanted to make a catalog and show what aligned products there are. Not certified yet, but just to give the users a list let them see what's going on. And we had our products there, and other people brought their products. And they're going to have another PlugFest in February. This was the one in Atlanta at GTRI was a practice PlugFest. The one in February is going to be there, inviting all the generals and all the top brass, and just to show off what wonderful things we're doing. And they're doing all these different categories, SBCs and GPUs and small form factor and everything. And we were particularly interested in the power supply. I just put our name next to the power supply because that's what we were demonstrating. And the problem is, there was a lot of chassis like the one on the left with 3U, maybe 300, 800 watts, fairly low power. And we have our 6U card, our 6U power supply card, which goes into a 6U chassis, which is a lot bigger. And our power supply is over 2,000 watts, 2,300 watts. And they invited us to a room like this with tables like this, and they say, here, go show your stuff off. And what do? You plug it into a wall. How do you get that much power out of the outlet in the wall? And we said, how can we show it off? We have nothing to do. So we went back to our engineers and said, what do you think we can do? And they came up with a very creative solution in about 2 weeks. What they did was they took our power supply, and we have it in production, and they said, well, theoretically, it can run backwards. And so what does that mean? We actually took one of the power supplies, we tried it out, and it actually worked. We took one of the supplies, we fed it with 270 volts DC. That supply produced a huge 180 amps of 12 volts and 40 amps of 3.3 aux. We fed the other supply, we put that as the input to the other supply, ran it backwards, It provided 270 back into the first supply, so all we had to take out of the wall was maybe 200 watts, and just to make up for the efficiency losses. And so we were able to actually show it in a regular conference room in a very simple way, and I think it was really creative. In 2 weeks they got it done. The only thing they had to do was there were blocking components in the supply that prevented reverse current. They had to take them out, and everything else was software. Instead of programming positive current, they programmed negative current. So I thought it was an interesting thing, and I just wanted to let everybody know. And I think it's just how flexible you can do. If you do the design from ground up and you have all the software built in, you can do a lot of different things with it. Here's our setup. Really fancy. Look at the fancy cooling that we have. We got the power supplies laying on the bench, doing 2,000 watts. We ran them for 20 minutes on the bench, not overheating. We talk here about providing power, air cooling, liquid cooling, water cooling, conduction cooling. But when you're only dissipating, you're producing 2,000 watts and you're only dissipating 95% efficient, you're only dissipating 100 watts, it's not too difficult to get rid of the heat. Not like you have to worry about with some of the processors that are out there. So this was the bench setup. We were monitoring everything on the computer, and you can see on the screen on the bottom, the one supply, if you can see it, but the one supply was on the left side was producing 3.3 volts, 3.299 volts, and 12 volts, 11.997. And the other supply is adjusted, the voltage is lowered in order to pull current from the first one. And we basically had the software set to pull about 180 amps on the 12 and 40 amps on the 3.3. And that's what both supplies are doing 2,000 watts and just feeding each other. So I thought it was a very clever idea. And you see also there's a Elma chassis monitor, chassis controller, and we're communicating with the supplies. The supplies are all VITA 4611 interface, and we're providing voltages and currents and temperatures and all of that so we can monitor to make sure nothing blows up. We're working towards a full tier 3, but it basically is providing the functions that most people want. And just another shot of the power supply in the bench, a little bit neater. And eventually, I think the ideal demonstration we would like to do is we'd like to have a chassis with 4 power supplies in it to demonstrate sharing between 2 supplies as a load and 2 supplies as a source. I think that would impress people, and they can try things out and and see how you can really make use of something like this. Okay, and our engineers put together a little description of regenerative power. It's been around for a long time. If you go on the search, you'll see regenerative power supplies. They're really useful for testing. When you're testing 100,000 watt things, you don't want to be buying it all from the utility. It'd be nice if your load took the power in and put it back on the line so you're not paying for it all. And it's nice that these supplies are fairly small and fairly cost competitive, even at VPX prices. They're fairly competitive compared to regenerative loads, and I think we see internally in the plant, we see a use as we're doing production testing on the supplies. We're testing 10, 20, 30 supplies at a time. It'd be nice to have a bank of these same supplies as a load, just making more of the same thing. They don't have to meet all of the altitude and shock and vibration requirements, but basically a commercial version of the supply. Again, just a little bit more about regeneration, load testing. We use it for performance verification. It's nice to be able to program your load to do that. This provides the opportunity to do that. We use extra. In the past, everybody had load cards. You can buy chassis with load cards, but again, that's all heat going to the plant, things you have to take care of. With this, it's basically very environmentally friendly. You're not using much power at all. And if you configure the design properly, you can actually do it. I mean, most supplies, you can't just take a standard power supply really and run it backwards, but if you design it like that from scratch, you can. Anyway, and again, the theory on regeneration allows input power to be significantly smaller, and we're only drawing 100 watts, a few hundred watts from the wall. If we're testing a big system, we're drawing maybe 1,000 watts and testing 100,000 watts. We're using basically the 4611 software to control it. Monitoring and setting current limits and setting currents and voltages and things of that sort. And it allows for pretty accurate testing of the supplies. And we can do power, we can do multiple supplies in parallel. I would like to have a demo system, that we can actually show this, as a redundant or paralleling supplies in standard operation. We see applications out there with some of the big chassis where they need up to 3. The biggest one I think I've seen was 6 supplies. Well, that was 6,000 watt supplies. So if you've got a 2,000 watt supply, that would be only you only need 3 cards. And that's a big thing we see with this design. Is there are a lot of systems out there that want to be upgraded. They have all the new processors. You have more capability that you can get out of it with the new processors, but the new processors take more power. And a lot of the platforms, like a F-18 or a ground unit, they have a certain size generator, and not all of them are able to upgrade the generators. But because of VITA 62 and because of the standardization, a bunch of people have been able to take the 1,000 watt card out, plug in the 2,000 watt card, and double the power to the system, double the processing power to the processors. And that's really the advantage of the VITA standard is, with nothing else, just plug in the card, you can upgrade and get a lot more capability, which is basically the idea of the standard, and it's been working. Again, a little bit more on the features of the supply: low heat, low cost. It's lower cost than bulky loads. The loads are wasteful. It doesn't require an external load. We've worked on we can work and power 7 supplies from the wall and standard wall outlet. So, because of the low load that we can take from the wall. We can test multiple supplies. Again, the 2,300 watt system only takes 240 watts of dissipated as heat, but because you have this supply, the load supply and the source supply are both dissipating about 100 watts. Again, we were originally talking about testing supplies, testing 100 at a time, big modifications in the factory, how we're going to cool the factory, what are we going to do with all the heat. Well, this basically solves the problem for us. Basically the same product solving the problems that it could have created itself. And, okay, VPX power supplies, again, our supply, the people see the advantage because it is over 2,000 watts of power. And it provides a big advantage to all the existing systems. The 95% efficiency, we have the data, tested it over a wide range of temperature, and it's pretty flat at 95%, over 90%, even down to a 20 amp load, all the way up to 180 amp load. And it's really cool, as you saw. We're probably going to do a little demo where somebody's going to come over and do a video and put their hand on the supply on the bench and not go away fried. And we're pretty proud of it. And again, we see in the product that we've done, we're doing a lot of DC to DCs, 270 volt in to VITA voltages out. But we can also do AC in. We have an AC version, single phase AC version, 3-phase to VPX out. We are doing DC in to AC out. The DC in to AC out, we're going to probably configure that for 28 volts in for AC, because people have systems where they want a generator, they need a little AC, it's a vehicle. Well, you can take the same card, put 28 volts in and generate AC out, generate single phase AC out or generate 3-phase AC out depending on the model you have. But the design is very, very flexible. There's almost no changes, all use common components. So this design can do an awful lot of different things. The AC could be single or 3-phase. And the other thing right now, we're building 3 different conduction cooled models. three different liquid cooled models, a conduction cooled model, and we're trying to make sure we can accommodate VITA 48, 5, 7, 8, 9, just by changing the cover. Working with some companies in the room here just to design covers, and we have one design, we've designed the power supply, and now we can do all the different cooling operations and all the different uses just by changing the cover. It actually is not always as simple as that, but in theory we can do that. And that's pretty much the message I wanted. I thought it was an interesting, unusual application for a standard product.